So if we're actually solving problems using this, the first thing is we're going to take a skateboarder jumps off the ledge of a skateboard park. His path is modeled by the function h is a function of d is equal to negative 0.75 d squared plus 0.9 d plus 1.5, where h is the height above ground and d is the horizontal distance that the skateboarder travels from the ledge, and they're both in meters. First, we're going to write a quadratic equation to represent the situation when the skateboarder lands on the ground. Well, obviously when they land on the ground, the height when they land on the ground is going to be 0. So I would say that 0 is equal to negative 0.75 d squared plus 0.9 d plus 1.5. What I'm actually graphing into my calculator is going to be y1 is equal to negative 0.75 x squared plus 0.9x plus 1.5. My window settings I'm going to use for this are going to be x is going to be min neg 1, max 5, and a scale of 1. And my y is going to be negative 1, 5, and 1. And then I'm going to get something that looks like this. And I can see this is where he started. He launched over and to the right. And then this is where he actually landed. When I solve for my 0, that's at the point of 2.1 and 0, which means that I can state the skateboarder lands 2.1 meters from the base of the ledge. For example 2, two numbers have a sum of 10 and a product of 24. Well, if two numbers have a sum of 10, I could say that x plus the other number is equal to 10, which means that the other number is going to equal x minus 10. Sorry, backwards. 10 minus x. These two have a product of 24, so if x times n was equal to 24, then I could say that x times 10 minus x was equal to 24. And here is my single variable equation. So, when I'm graphing this out, I'm going to state that y1 is equal to x bracket 10 minus x. y2 is equal to 24. I'm going to change my window settings. I'm going to say that x is going to be negative 10, positive 10, and 1. And y is negative 10, positive 30, and 5. And then, when I'm graphing this out, I'm going to get something that looks like this. There's one equation. There's the other equation. and where the two lines cross is going to be my solution. So in this case, they cross at the points of 4 and 24 and at 6 and 24. Well, if x was 4 and n was 10 minus x, then n would be 6. If x was 6, then n would be 10 minus 6, which would be 4. So no matter which way you look at it, the two numbers are 4 and 6. Last example. The profit P, where P is a function of n, is equal to negative 0.1 n squared plus 100n minus 21,000, a particular company makes from selling its products, where n is the number of products sold every single month. The business hits a break-even point when its profits reach 0. At this point, the business is neither making a profit nor losing money. Determine how many sales a company needs to reach this point. Well, when the profit is equal to 0, I'm going to have 0 is equal to negative 0.1 n squared plus 100n minus 21,000. And that's what I'm going to graph into my calculator. Y1 is equal to all of this. I'm going to have to change my window settings to make this work. And in this case, I'm going to use the window settings where x is going to be between negative 1,000, negative 100, positive 1,000, and a scale of 100. Y is going to be between negative 25,000, positive 5,000, and a scale of 5,000. And I'm going to see something that looks like this. Now, my x-intercept that occurs, well, I know that the full function of this is not really necessarily going to come down. If I keep selling more, then it should actually just wind up leveling out a little bit. But this is just reaching up to the vertex, or where my maximum revenue would basically stabilize based on the amount that I'm selling and the production costs. So really, to reach the break-even point, I'm just looking for this x-intercept on the left. And this occurs at 300 and 0. Which means that I would need to make 300 sales per month. When it says, what conclusion could the business owner make from the solution to this quadratic? Well, if they can't sell at least 300 units per month, then it is not worthwhile to produce. If they can't make the break-even point, there's no point in making the product.